Hello everybody, Aditya here, and we will be covering the US National Chemistry Olympiad 2020 local exam. So let's begin. Number 1. A 250-liter sample of butane gas measured at 22 Celsius and 1.2 atm pressure is combusted completely into carbon dioxide gas collected at the same pressure and temperature. What volume of carbon dioxide is produced? So this essentially is just a gas stoichiometry problem, a classic case. So we first have to balance the combustion reaction in order to find the stoichiometric ratio. So the balance reaction of butane's combustion is so we have like a 1:4 ratio of carbon dioxide, butane to carbon dioxide. Now we have to find the moles of butane using Pivnert. So when we solve for N, N equals 0.123 mole of CH410, right? Now we're using the stoichiometric 1:4 ratio to find the moles of carbon dioxide, so which is essentially 0.123 mole of CH410. So for every 1 mole of butane gas that reacts, you get 4 moles of carbon dioxide. And that gives you 0.492 moles of carbon dioxide. And then we just use PV equals nRT again. Solving for the volume, we just plug in our numbers. And we get the volume will equal around 10 liters, which is our answer, and that's C. Moving on to number 2. So, how many hydrogen atoms are in 2.5 grams of pharmacolite? So we're going to do pharmacolite equals PC, right? So we have 2.50 grams of PC. Now we want to find the moles of that using simple molar mass scheme. Now we have that amount of moles of PC. Now, look at the formula unit of pharmacolite. For every 1 formula unit, there's 5 hydrogen atoms. So we're going to use that ratio. Because we have 1 mole of PC, because of this, when we have 1 mole of PC, we'll have 5 moles of hydrogen atoms. Because each formula unit contains 5 hydrogen atoms. So we use that, and then we use Avogadro's constant, atoms of H, and this gives us atoms, or D. It's an easy problem. Now number 3 is a little long, so let's begin. So methanol is produced industrially by catalytic hydrogenation of carbon monoxide, according to the following equation. If the yield of the reaction is 40%, what volume of carbon monoxide measured at STP would be needed to produce that amount of methanol? So what's the percent yield? So percent yield is the actual amount over theoretical amount times 100. Now, if our percent yields 40, and then the actual amount we get is that amount, 1 million kilograms of methanol, then we must find the theoretical amount to account for the inefficiency of the reaction. So we have 1 times 10 to the 9 grams. So we want to find X in this equation. And your X, or the theoretical amount, equals 2.5 times 10 to the negative 9 grams. from here is just simple stoichiometry. 2.5 to 10 to the 9 grams of C3OH. So then we just use simple stoichiometric ratio. Feel free to skip forward if you find this redundant. 1 mole of C3OH equals 1 mole of CO, and then that gives you 7.8 10 to negative 10 to 7 moles of. Let me just use V equals nRT over P, and that gives you 1.7 10 to 9 liters, or C. Not that hard of a problem. Let's begin to number 4. Number 4 is pretty easy and straightforward. So what volume of 18 molar sulfuric acid must be diluted to 250 ml to afford a 0.55 solution of sulfuric acid? So this is just a simple and easy M1 V1 equals M2 V2 problem. So now we have 18 molar sulfuric acid must be diluted. Yeah, so then we'll plug in 250 ml. You can plug in ml because the units will cancel and you'll get ml as the final volume. So then 0.55. Oh, oops, we had 250 ml here, but you get the idea. V1, and when you solve for V1 you will get 7.6 ml, or which is C. Move on to number 5. So we're going to ask, what is the concentration of hydrogen peroxide in a solution that is 30% by mass hydrogen peroxide and has a density of 1.1 grams per milliliter or centimeter squared cubed. So for this type of problem, we're going to assume that we have a solution of 1 liter. So it's easier to find the concentration of hydrogen peroxide. So we're going to assume 1 liter. 1 liter solution. Right. Now, thus the density will be will be 0.100 grams per liter. Now what's the mass percentage? Since the mass percentage is 30%, right? That means we have 0.3 grams of hydrogen peroxide per 1 liter. Just using simple stoichiometric ratios. We get this. We get the molarity, which equals to 9.8 molar, or A. Pretty simple. Now number 6 is a little different from your regular stoichiometry problems. The USNCO tries to throw in a bunch of stoichiometric problems that involve system of equations. So here's how to solve this. So a 5 gram mixture of potassium sulfide and potassium chloride contains 2.8 gram potassium. What percentage by mass of the mixture is potassium sulfide? So we're going to set up our variables. So our X is going to equal our K potassium sulfide moles, and our Y will equal our potassium chloride moles. Now, we have a 5 gram mixture of potassium sulfide and potassium chloride. Now I want you to pause this video and write down the systems of equations that will help. I mean, if you didn't get it, then you're watching this. So then we're going to write 5 grams equals to the molar mass of potassium sulfide times the moles plus the molar mass of potassium chloride times the amount of moles it has. So this will give you the total mass of the mixture. Now, You also want to write down an equation that accounts for the 2.8 grams of potassium. So you want to write 2.8 grams of potassium equals, so you want to find the combined moles of potassium in this mixture. So you'll do this way. So you're going to have, let's take a look at K2S. Since if K2S has 2 moles of potassium per 1 mole of this, you write 2x. And since this 1 mole of potassium chloride has 1 mole of potassium, you'll write plus y. So this is your total amount of potassium moles. And then if you want to find the mass, if you multiply this by the atomic mass of potassium, you'll get that amount of mass. Now, if you solve the system of equations, you'll get x equals 0.08 mole of potassium chloride. And if you multiply this by the molar mass, you'll get 0.97 grams. And if you divide that by 5 times 100, you will get 19.2%, or B. So this is a little different problem. So now moving on to the quick and easies. Number 7. With salt and water dissolves to give a pink solution. The answer is, you must know right on the top, is A. Cobalt is pink. Now what's copper? So it's A. What's copper? Copper 2+ is blue. Iron 3+ in C is yellow brown. And then zinc. Zinc is colorless. Let's take it a step further. You know why zinc is colorless? Now, when you have an ion in solution, right? It's not just a free ion. The cation has a positive charge, so attract water molecules to an ion dipole moment. Usually transition metals have around 6 water molecules attracted to it. Right? Now, the water molecules interact with the d orbitals of the zinc ion, cation, right? And I'll erase some of the d orbitals in energy due to repulsion, dd splitting. So read up about crystal ligand theory if you're more interested about this. So then in octahedral arrangement, 2 of the d orbitals will be raised in energy. Now how many d electrons does zinc have? Zinc 2+ has 10 d electrons, a d10 metal. So we're going to fill out everything. Now, color usually arises by the excitation and then the relaxation of electrons. But the problem is there's no space for the electrons to move to a higher energy level. Thus no color could be achieved. Same thing goes for D0 metals. Alright, let's begin. Let's move on to the next question. Number 8. Okay, number 8. So we have ourselves a burette, right? And then you read a burette like this. So if we have 6 ml, and then you have 7 ml, you read it kind of backwards, right? So then if you go past the 6, if it's below the 6 ml mark, this is 6.5 milliliters. So you can easily cross out B and D because it did not go past the 7 ml mark. It's not below the 7 ml mark. But now, the small markings in the burette all imply 6.1, 6.2, 6.6. They all imply a second significant digit. But when you read or record a burette, that's not enough. You have to add an extra significant digit, right? So it'll not be 6.6 ml. You're going to add another significant digit, like in 6.63 ml, to account for more precision It is your degree of uncertainty. So thus C is the answer. Moving on. 9. Some good descriptive chemistry. So a strip of metallic zinc is placed in a beaker containing dilute aqueous copper nitrate. Which statement takes place? Okay. So you want to memorize your reactivity series, right? So you always want to know that copper, gold, and I think silver, right? I'm not sure, but I'm pretty sure copper is a good, like, it wants to get reduced easily. It gets reduced easily. And zinc gets oxidized easily, right? So because copper has a higher reduction potential than zinc will lose its electrons more easily and copper will be reduced easily. So reaction takes place as this. So we have zinc, right? Zinc solid plus copper 2. Zinc will get oxidized and become zinc 2 plus cation. And then copper will get reduced. So which of our options will match this equation? No reaction, we can cross it out. I just wrote down the reaction. The mass of zinc metal strip decreases. Yes, it did. From solid, you're forming more ions in solution. And the zinc is oxidized. So B is our safe answer. A white precipitate of copper nitrate. No, this is wrong. Nitrates are always soluble in water. Nitrate compounds. Bubbles up, no. No need to overthink it there. So it's B. Okay, moving on. Which element does not have multiple allotropes? Okay, you must cross our carbon out of the way. You can find diamond or graphite. Those are two common allotropes of carbon. And they will get, and there are multiple columns, so you can cross out A. Oxygen. Now, what's it? And the definition of an allotrope is like a compound that has only one element in it, but in multiple forms. So let me give an example of oxygen. You can have oxygen or ozone. These are allotropes. So you can also cross out B. Now fluorine. I can't think of anything. I mean, if you can't think of anything, just leave it out. So we don't know about C. Now, D. Now you just have to know this. It's kind of a guessing game at this point. But phosphorus can be in white or red. The red, I think, is used in matches, and the white is like used in like bombing, sadly. So since we can cross out D also, the answer must be C. Fluorine doesn't have multiple isotopes. Moving on to 11. Alright. Which reaction is not exothermic? So, dilution of concentrated hydrochloric acid in water, okay. So, when the dilution of acids in water is always exothermic. Remember the phrase, remember like teachers always tell you, always add acid to water? Don't add water to acids because it has very exothermic reaction. So using that knowledge, you can easily cross out A and B. Now, between C and D, you're going to be a little confused. Which one should I choose? But the thing is, by size. You see that the hydroxide ions, right, are smaller in size than the bicarbonate ion, right? And due to the hydroxide ion's smaller size, it will have stronger dipole ion interactions with water. Let's take a look at Coulomb's law. So Coulomb's law is Q plus, Q minus, energy is proportional to it. Since the distance decreases, right? And it will release more energy. It will release energy, a lot of energy, due to strong interaction, thus making the dissolution of sodium hydroxide in water exothermic. And thus the answer is D. Now moving on to 12. Now 12 is a pretty hard question. So there's a lot to read and a lot to analyze. So let's begin. The molar mass of a volatile organic liquid is measured by weighing the mass of an empty flask shown in volume, of known volume, adding some of the liquid, heating the flask in a water bath until the liquid has just vaporized completely, then sealing the flask, letting it cool, and remeasuring the mass of the remaining organic compound. Which error would lead to a calculated value of the molar mass that is lower than the theoretical value? Okay, so to find the molar mass of a compound, we need two pieces of information. We need to find the grams and the moles in the sample. And this information will give you the molar mass, because molar mass is grams over moles. So now, how would you find the mass, or grams? Now, it says that you measure the mass of the empty flask, then you remeasure the flask with the remaining organic compound. So your grams essentially is just the mass is going to be remeasured. How do you spell remeasured? Remeasured flask minus initial measurement, right? So you're going to find, by doing that, you're going to find the mass of the remaining organic compound after you, seal the flask, right? So then that's your mass. Now moles. How the heck can you find moles? So I think what you do, I'm not completely sure, let me know in the comments. I think you do PV equals nRT, right? PV equals nRT, right? When you seal the flask, you measure the pressure inside, right? From this you can find the moles. So PV equals RT, right? And from analyzing these variables, you can find the answer that will have the lower molar mass. So let's begin. So the flask is not sealed completely after the last of the compound vaporizes. Okay, I think this could work. Because if you if you fail to seal the flask, not probably the measured amount of grams will go down, right? So that means if this goes down, the molar mass will go down. Now for B, the organic compound dimerizes to an appreciable extent in the gas phase. So when it dimerizes, right, so you have 2 moles of a gas forming into 1 mole of a gas, and that will decrease the pressure, and that will decrease the calculated amount of moles, which will overestimate the molar mass. So B is wrong. The barometric pressure was assumed to be 1 atm, but in fact was greater than 1 atm. Now same thing applies. You think the pressure is higher, so you underestimate the moles, and then you overestimate the molar mass. So see that. The volume of the flask, the volume of the flask is, in the calculation, is smaller, right? So the volume of the flask goes down. Okay, you underestimate the amount of moles, and then the molar mass goes up. So that's wrong. So we get A is our correct answer. Now, for this question, in Chemistry Olympiad, you will not know every question by heart. But like when you analyze, if you don't know the correct process, right? Like I did here, you can use some of the reasoning and interpretation of the problems. So, and doing that, I got the correct answer. So I hope this video helps, and please leave any suggestions and comments or questions, and please leave a like and subscribe. Thank you.